Okay, I'm going to start because we have little time. My name is Holger Woltersdorf. I'm working for Fortune Globe. It's an e-commerce company for the fashion industry in Dresden, in Germany. And I'm obviously coming from Dresden, Germany. And I'm one of the organizers of the PHP user group in Dresden. And before I start my talk, I have a little ad. So we are organizing the PHP Developer Days in September in Dresden. And here you can see maybe some familiar faces of our lineup. So Andre will also be there. We have 6 workshops, 2 full-day workshops and 4 half-day workshops, 11 conference talks, 4 unconference talks. We have some side events. We have a WurstCon at the end, and you can buy tickets on that web page. Okay, let's get started. So this talk is about CQRS and event sourcing and should give you a brief introduction to both topics. So I will skip some slides because this talk is usually a 60-minute talk. So if you have questions, just come to me later on and maybe I can show you some more details. Okay, CQRS, Command Query Responsibility Segregation. I will stick to the abbreviation if it's okay for you. CQRS is evolved from the CQRS pattern. CQRS implementation pattern was first stated by Bertrand Meyer in the 90s. He was working on the Eiffel programming language and very old stuff. So CQRS, so command query segregation, describes a semantic implementation pattern for object methods. So queries return results but do not change anything, and commands change the object state but do not return anything. So that's a bad example. So if you want to have a number that should be incremented, get incremented number would violate the CQRS pattern. So the good version is this one. So get the number and increment the number in 2 different methods. So that's basically CQRS. CQRS is an architecture pattern. It's not applied to just objects. So it was described first by Greg Young in his CQRS documents in 2010. And the main idea behind CQRS is the separation of responsibilities for read and write operations. So the thing is that you can change things on one side and read things from the other side, or the current state from the other side. And the main advantage, I will also show you later, is that you can give each side an appropriate storage. So that is in the praxis. You would have, for example, for the read side, a more speedy storage than on the write side, because usually write operations are considered to take longer than read operations, and most of our websites today are more read intensive than write intensive. So skipping the demo, if you look at your application, usually you have a request handling layer that knows HTTP or any other protocol. Then you have the business logic layer, so there are the business rules, and you have something like a persistence layer. Of course, that knows databases. The good news is you can apply CQRS to all of them, and that would look like this. So you have a site where you say, okay, I want to change something, so you send write requests to that site. You have your business logic that is validating your request, and then you change your state. On the other side, you send read queries, usually GET requests. You have maybe some slide view logic. You will see if you properly apply CQRS, you won't have any business logic on that side because you only need business logic when you write something or change a state. And you have some representation. So representation could be another storage Yeah, and how do we get from here to there? We can add, sorry, my clicker is a little fast today. Yeah, so for example, we can use a publish subscribe pattern. If we change the state, we can publish an event or something like that, and the representation can subscribe to it and change itself. So when the read request is coming, we have a current representation. If you have multiple representations in different formats, for example, you can also do something like this. It doesn't work. No. You can add a message broker or an event bus or something like that. And you have multiple representations, and you can subscribe asynchronously to those events and prepare your representations in parallel. That, of course, means that you have eventual consistency on the read side. Depends on your current use case. So if that is OK or not. In most cases, it's quite OK. So quite a small example. So we are working for a fashion company. To illustrate how CQRS works is this example is based on a newsletter registration. So when you want to subscribe to the newsletter, you have to fill in your name and your email address. And then you send the form. A form request is usually a post request because you want to change state. Yeah? So you want to initialize a newsletter subscription. So of course, some errors could happen. In this case, the error would be returned to the read side via session. So we just keep the errors in the session of the user, and we can display that in the form. But what you see here is a GET request, because after we have done the validation on the POST request, we just say, OK, there are validation errors, and we do a redirect to the GET request, so back to the form. And we just store the intermediate information in the session, so the error information. Big advantage is you can now reload this form as much as you want. You won't trigger the POST request again. So that's one of the main advantages in general of CQRS. So I would skip some code. In the end, when you finished your subscription, so your write logic was OK, you persisted the subscription, you just show a done or a thank you page. And again, that is a GET request, so it's just a simple view. And the information are coming from the session or from the database. That could even be a static HTML page that you have prepared as a representation. And it, of course, can be deleted after the subscription is finished. So usually a subscription for newsletters is double opt-in, so you have to do some more action. So then we have a problem when we send an email and the user needs to confirm his subscription. There's usually a call to action button like this. And the problem is we cannot send post requests out of emails. So we only can send GET requests. That's why we are showing the form again on the website, and he needs to click on the form so we can send a post request. Of course, there are options that you can proxy that GET request to a post request, but please respect the HTTP verbs. They are there for a reason. For example, this one, get and head methods should not have the significance of taking action other than retrieval. That means they are read-only and should not be used to change your application state. Yeah. OK. Like I said, don't change state from GET requests. For example, what you can do is, instead of just saying, hey, confirm your email address, you can ask further questions to the customer on that page. And you can say, OK, what kind of T-shirts do you like? How often do you want to have the newsletter? And so on. And then again, you are fine with the GET request at the end, and you don't have any view logic. So I'm maintainer of a framework that is supporting CQRS if you like to have this one. So how does that look in persistence? So when I added my subscription, usually in a sequential database, it would look like this. Full name, email address, how often do I want to have the email, when did I subscribe, when did I confirm, and maybe when did I unsubscribe. So, and a second list where I see what kind of topics I'm interested in. But what happens if I subscribe again, for example, for other t-shirts, and change the interval? So in the end, my table would look like this. I changed the interval, and I subscribed again. My unsubscribed date is vanished. And I only have one relation in the topic table. So developer reaction, yay, everything worked. The admin says, hey, your database is clean. And your business analyst says, you're fucking insane because you just erased valuable data. So if we have a look at what we have lost, so we actually have lost any information about the first subscription. So we don't know when the first subscription happened, we don't know when he unsubscribed, and so on. So the only thing that stayed the same were the email address and my full name. And what else have we lost? We lost analyzable data about the user decisions to react on change or reactive on change subscriptions. So in applications like this, the application state is only observable, but only on an exact point of time. So if you look at the database, you see what the current state is. But you don't know what the state was yesterday or before yesterday. That's the problem. So, and at that time, we could add event sourcing, because event sourcing allows us to face that problem and maybe solve that problem. Event sourcing was first mentioned by Martin Fowler in 2005 and was also already part of the CQRS papers from Greg Young. And the pattern itself is way older because it was already used in accounting software in 1930 or something. So the key concept is record all changes to application state as a sequence of events. That's basically the idea behind that. So let's remind of this picture that we had before. So how do we come from a state change to a representation? So what we have to do is we have to look at our right side and at our representation. And when you do event sourcing, what you're doing is you're replacing your state, so your database, with an event store. And when you do your business logic, you first read all the states or changes that you made to your event store before. Then you apply your new changes, and the new change is recorded. And after that, you again can publish this event or these events and update your representation. In more detail, it looks like this. So you have something like a command or a trigger or whatever. So usually that's just a method or an object that is sent to an event bus or something. You have your business entity, and your business entity is rebuilt from a history. That business entity could be any domain model that you have in your application. It depends on the implementation that you choose for event sourcing. So there are different implementations out there. So the event store holds a history of changes, and you retrieve that history for that particular business entity. Then you have a business entity that is in the current state. And then you change the business entity, which emits new events, which go back to the event store. Now we'll show you how an event store will look like. So first, you have something like a sequence. So that is a number that is incremented over the whole event store, regardless of the entity. And it is used to sort all events in time. The second one is the stream type, stream ID, and stream sequence. The stream type is, in our example, the newsletter subscription. So our business entity would be the newsletter subscription. The stream ID is, for example, a UUID for me. And it could also be a UUID for another person, then it would be another stream ID. And we have a stream sequence. The stream sequence, again, is an incrementing number. But the difference is that this number is incrementing for my particular entity. So I can see all my events for my business entity sorted in that table. Yeah, then we have an event ID. Event ID is nothing more than a simple sentence. So it could be plain text. That is the name of the change that you did to your application. We have the payload. The payload is the actual data that you changed. And that should be contained, or that should contain everything you need to restore your change, or to replay your change. You should choose a format for the payload that is technically independent, so something like JSON or XML, whatever. But don't use serialized classes, please, because then you get a problem. Yeah, and we have a timestamp when the event occurred, actually. But do yourself a favor, do not rely on timestamps for sorting, because when you have events that occurred on the same time, because you have a distributed system, or if you have two servers that have different time zones, or two servers, different time settings, you cannot rely on timestamps. So that's why we have this stream sequence and the global sequence for sorting. And then you can add, optionally, metadata to the table as much as you want. That's just for you to see where did the event come from, in which country did the event happen, and so on. So that really depends on your application and on your use case, what kind of metadata you can put here. So this is my first subscription. I initiated the subscription, I changed my interval, I assigned 3 topics, and I confirmed my subscription. And this is my second subscription. And the point here is that I called another event here. So I didn't say subscription was initiated again. So I choose subscription was reactivated, because it has a different semantical meaning to reactivate my subscription than just do a new subscription. So that wouldn't be any information for us. And that is very important. Also, if you think in the meaning of of domain-driven design, naming things is hard, but you should name your things really in the manner of process that you have in your application. And that's what you're actually doing when you're using event sourcing and domain-driven design in combination. You try to find names for your events that are semantically meaningful to you, to your business, and to your application. And to see why that is also technically relevant is when we have a look at the payload. So when I initialize my subscription, I have to give three properties. So I generate a subscription ID. I have to give my full name and my email address. And when I reactivate my subscription, the only thing that I need to have in the payload is my subscription ID, because that's the one I need to reactivate it. The rest will be the same. So also here a hint, do not add previous values to payload. They are already recorded. The thing is, when you do event sourcing, you need to stop thinking relational. You need to start thinking temporal. So you always have to think about, okay, what is my current state? What happened before? What information do I have? The thing is, you don't lose information because you record everything. Every change is recorded. So you can rely on that information later on. And so event sourcing is a very good way to think about what kind of connections do I have to make in my application to change my state. And you will be surprised how less information do you actually need. Yeah, so how does an event look like, or an event interface? So you have the stream ID, you have the event ID, you have the payload, and you can reconstruct that event from payload. So when you retrieve your history out of the event store, that is usually something like a JSON payload or something else, you would get the event reconstructed. Usually, an event is enveloped into an event envelope, where you have a header and an event. And the header is there for storing meta information or the technical information that you need to operate on the event store. And that's something like this, the stream type, the stream ID, the stream sequence, when did the event occur, and so on, and all your metadata. Important things about event sourcing, the event store is immutable and append only. So it's just one table where you add rows at the end. So you never change your event store because it's your source of truth. And also, if you think it might be slow, it isn't. So I've done multiple event sourcing implementations with millions of records in one table. It's not slow because you sort by an integer. That's your sequence. And you just select from top to bottom. Never have to make any joins, anything else. So it's not slow even if you use MySQL. So like I said, use technology-independent payload formats. Events are also immutable, so you should never change an event because it's a fact that happened in the past and should not be changed. Separate payload and metadata from each other, and the event stream is a sorted list of events. That's the only thing, just as that explanation. And you cannot instantiate your business entities without an event stream. So in an event-sourced application, you don't have any entities that are meaningful to your business without reconstructed from a history. So I will skip the code examples for that because we are already quite on time. Yeah. What kind of advantages do we have now? So what questions can we ask in our example? So what was the unsubscribe ratio in 2016, for example? Now we can get all events or unsubscribe events and show, okay, in 2016 we had like 500,000 unsubscriptions, but we had 3 million subscriptions. How many users reactivated their subscription? That would be an information that we wouldn't have before. How many users did it? And how many users did it once or multiple times? Which topic was removed the most? How many users changed the interval? So now we have the opportunity to answer questions that we may didn't think about at the beginning when we started implementing our application. And those are typically questions from business analysts or from your management. And if you have a relational database and you just erase your data in multiple ways, yeah, you get sweaty when you get that questions. So, yeah, we remember this one. So we have an event store. We publish the events to our representation to update the representation. In the words of event sourcing, it's called projection because we are projecting the current state of our application to a different data storage. That projection could be everything. It could be a static HTML file. It could be a Redis. It could be a MongoDB, whatever. Yeah? So, and again, you can do that asynchronously and have eventual consistency. For these projections, there are 3 different types. One are push views. That's mainly the thing that I showed. When you push the event to the representation or to the projection, then the view is the view is updated automatically based on that event, on that trigger. You can also have pull views because when you push one event to the projection, you may not have all information to update your current projection. So that's why pull views also exist, and they can access the event store and get particular events out of the event store to get more information to update the projection. And you could also have mixed views, so they are triggered by an event, and they can also pull some information. Yeah, please note, projection should not convert state information to the best data format for the read use case. So projections are there to be read very, very fast. So use a format that is, in the best case, static, or something like a in-memory store or document database. So whatever fits your current use case. And the cool thing is the representation could also be another event store. So if you have an application that produces like 10 million events per day, you will someday get the problem that your database is too big and that you cannot query fast enough for certain events. But what you can do is use a representation or a projection of just a simple or a sliced event stream, for example, for just newsletter registrations. So summary, what are the CQRS advantages? So we have separate input and output handling. We have the opportunity to optimize each site for its purpose. So if you have an application that is very read intensive, you can optimize the read side for speed and maybe not care about the write side because it's slow, but hey, it's okay. But could also be the other way around. That's a very good thing. So for example, we have in e-commerce shops like 95% read requests and 5% write requests because we are showing a lot of product information pages. Yeah, of course you have clean code, you have reusable queries and commands, you have a decoupling of read and write side, which is simpler to test. You have no unintended side effects. You are technology independent for each site, so using different data storages, so you can also use different technologies, like I said, and yeah, and you can also, it's a good prerequisite for scaling, because scaling the read side is very easy, because it's updated on one side, and yeah, you can just add some slaves, or you can just have update multiple instances when you do it asynchronously. That's not a problem. Advantages of event sourcing. We have a high scalability because we can slice the event store. You can even use one event store per business entity if you like to. So that would be one table for each entity. We have a simplification of storage because you don't have to bother anymore with any relational databases. So it's a one-size-fits-all solution. You just have one table, and that's it. So you have the traceability of all changes ever made to your application. So that's why the talk is called the application that never forgets, because it doesn't. You can have retroactive data analysis at any time. That means you can answer questions that were made in the future you didn't think about when you implemented your application. You can restore your state of your application to any given time since you started recording events. For example, if you have your financial report for 2016 to do, you can restore your complete application to the state of December 31 on 2016. And that's a very cool feature. And of course, you get things like logging and everything out of the box because you have all the events. You just can add a listener or subscriber to the event and log them anywhere, or produce any log messages that you need. If you change something in your business logic, you can just replay your events after you fix the bug to update your representation or projection. And it is easy to backup because you only need to backup one database. Questions?